and today I'm going to be teaching you about Boolean logic in Java. So what is it? Where did it come from? It was created by a man named George Boole in 1854, and he derived it from formal logic using and, or, and not. These phrases were then implemented into creating gates, which are used in hardware nowadays. In programming, we use it when we create the if and while statements, like if the first variable and the second variable are true, then this next statement will be executed. So that's when we use it in programming. In real life, in hardware uses, people use it to create gates, like circuits using the AND and OR gates, quite commonly in hardware design. What does it look like in Java? Right now, the AND gate looks like two AND symbols beside each other, and as you can see, is variable A and variable B are next to each other. OR is two vertical lines, and not is an exclamation point, and that's an example of how we would use not in Java. So what are truth tables? Truth tables are basically define what each gate does. So when the input for A is false and the input for B is false, what does that output look like? So same thing in every single one of these situations. Here I'm going to go through each one of them. So when the input for A and B is false in the AND gate, the output is also false, and it's false all the way down until both A and B are true, then the final output is true. When we use this in Java, we go when the value of x is and the value of y are both equal to their specific number, then the following statement is executed. That's how we use them in Java. Or gates are when only used when one or the other is valid. Actually, this last one should also be a 1. So right here, let's see. This should say 1. That's really ugly, but yeah. So an OR gate works when one or the other or both inputs are true, and the output will be true when at least one of the inputs are true. A NOT gate is basically, it reverses the value of the input. So if you put in false, it'll come out true. If you put in true, it comes out false. And so there's 3 basic rules that we have to be careful with when using it. Associative is basically just like regular algebra. When A or B is in brackets and or C, it's also equal to A or B, or A or B or C. And so you can also do those with AND gates, the same exact. You just replace it with AND gates. Commutative property is when you can switch the letters around and it'll still be the same value. And the identity is where if it says A or false, then it equals A, and if it says A or true, then it also equals A. So it's the same regardless. Now, what's really important is De Morgan's theorem. De Morgan's theorem basically says when you use a NOT gate with a gate with an OR gate on the inside, it switches the gate to an AND gate and creates all the values as NOT. So I'll go more in depth in that a little later, so I can show you how it goes. And same thing, just flip around with that. So let's do a practice problem. So I have this practice problem listed right here, and so I usually don't do it in this format. I like a different format, so I'm gonna rewrite it how I usually see it. The plus sign is our OR gate, and then that line on top is our NOT gate. This multiplication sign is representing the AND gate, and then BA, and this equals function 1. So now, if we want to simplify function 1, how do we do it? Okay, first we can use De Morgan's theorem, and we can break down this first portion. So it's going to be A naught, or and B naught, and then that and stays the same with it being A or B or equals F1. So basically that's how we can simplify it down. So it's going to look like this in the end. A, B, B plus A. And now, so some simple rules that you just have to memorize is that if you're multiplying to the same thing, it equals the same thing. So it's going to be A, B prime plus A prime. And when you add, so that's just going to be, yeah, that's the final answer. So what it looks like in JavaScript in the Java world is A and B, excuse me, with exclamation point on front, OR gate A, exclamation point A. And that is basically Boolean logic. Thank you guys for watching, and I hope this helped.